All right, so if I'm going to name the tangent, remember a tangent is a line, and so I name that with two letters. What two letters name this tangent?
TX.
TX, very good. And then the point of tangency is the point where it intersects the circle, and that would be point
T.
T. And then the points in the interior are which points?
I or P.
I and P. And then the point on the exterior,
X.
everyone okay with that? The only point on the exterior is X. T is neither interior or exterior because it is on the circle. So, the first theorem that we're going to look at says that if a line is tangent to a circle, so in example 2, AB is tangent to the circle. If that is true, then it is perpendicular to the radius drawn to the point of tangency. So this is the point of tangency. This is the radius drawn to it. So this radius and this tangent are perpendicular, which means they form what kind of angle?
Right.
A right angle. And so right here is our right angle. And now we have a right triangle, and we know two of the legs. So what theorem can we use to find the missing leg? Pythagorean theorem is actually the hypotenuse that we're solving for this one. So now, again, that's where I'm saying it's not new math. So the theorem is, if we draw this tangent line and then we connect it with a radius, then they're perpendicular. Therefore, we can create a right triangle that we can now use Pythagorean theorem to solve. And so we have a leg and a leg. And so that is addition, 12 squared plus 5 squared. And then we take the square root of that. And that will give us AC, which is not what we're being asked to find, but that is how we have to start. Now, I will say, if you remember your Pythagorean triples, you will save a lot of time. Does anybody know the Pythagorean triple of 5, 12?
No.
Okay, so if we solve the square root of 12 squared plus 5 squared, what do we get for AC?
13.
It is 13. And now that's not what we're asked to solve. But I want you now to look at this. I want everyone to look at this. And I'm going to give you a few minutes, or a few seconds. And I want you to think about what it is now. It's one simple step that we can do to figure out this x. Because we have information that just isn't labeled yet. But we know something about AC, or part of AC. So when you have it, let me know. When you think you know. Or we've got one. All right, go ahead and tell me what you think.
What do you just subtract 13 minus 5?
Why 5?
Because it's the radius.
Because it's the radius. From here, center, to that side is a radius, which is 5. And so, if you know that that is 5, and that this whole side is 13, then now you just subtract 13 minus 5, and you get?
8.
Fabulous. Outstanding. Yes. So again, it's really not new math. It's the same math skills that we've been using. It's just a new truth in geometry. So using that theorem that says if you draw a tangent and connect a radius to the point of tangency, you form perpendicular. That makes angle A a right angle, so we'll start there. And then it says that DE is 16. What does DE represent in that circle? Not circumference, but the diameter. So if all the way across is 16, halfway across is going to be
8.
So each of these radii are 8. So I'm going to, instead of writing 16, I'm going to do the radius of 8 because that's going to be more helpful for us. And then it says that E to B is 9. That's just given. And now it wants us to find AB. It wants us to find this side, this tangent here. And that tangent happens to be a side of a right triangle. And so how are we going to solve that one? Pythagorean theorem. We have a leg and a hypotenuse, and what do I need to do with these two sums? Or I need to add those two sections rather. And 9 and 8 is 17.
Squared.
And so I have a leg and a hypotenuse. How do I know it's the hypotenuse? Because this is the right angle. The hypotenuse, remember, is always across from the right angle. The two legs make the right angle. So I have a leg and a hypotenuse. When I have a leg and a hypotenuse, I subtract. This is also a Pythagorean triple. So if you remember your Pythagorean triples again, you can save a lot of time. But if you do that math, 17 squared minus 8 squared, and the square root of that is 15. And that is what that asked for. It asked just for that side, which is AB. So AB is 15. So again, New theorem, not new math. All right, the second theorem today states that if two segments from the same exterior point are tangent. So here in our example, here is the point, here are the segments that are drawn, and they are both tangent to the circle because they touch that circle in one spot. So when they are tangents from the same point, then those segments are congruent. And what does congruent mean?
Equal.
They are equal. So this side is equal to this side. And so mathematically, how would I solve for x? Put them equal to each other. And now again, not new math. You're just solving now for x. So we add 3.
Yep, this is true.
And so 2x equals 30. And then the next step is to divide by 2. So x is 15. And so the solution there is 15. So using that theorem for example 5, find all 4 of those indicated values. So let's start by labeling what we know. We have 2 theorems that we can use now to label here. So I just learned that AB is congruent to AD. And then what do I know about this angle B and this angle D? They are congruent, but how many degrees are they? They are 90 degrees. So I'm going to put a 90-degree angle there. Yes? And then if I were to draw a line from B to D, I'm just going to put my pen there because I don't want to draw it in because I just want to point this out. What kind of triangle does that create if these two sides are the same?
Equal.
Isosceles. And what do we know when an isosceles triangle and we cut a perpendicular line? What happens to that angle?
It doesn't exist.
What does that line do to that angle? It bisects it, so those two are equal. So I just want you to keep that in mind. All right, because that's something we have already learned, and we just need to remember that when we have an isosceles triangle and we cut it, when we draw a line perpendicular to the base, it does cut it in 2 equal pieces. But the first thing I want to do is solve for x, and to do that, I just do what with 2x minus 13 and 48? Put them equal to each other. Very good. And then solve that algebra. So we start by
Plus 4, plus 18.
adding 13. And so 2x equals 48 plus 13 is 61. Divide by 2. And x is 30.5. Fabulous. Am I going too fast?
Well, I think I might be going.
All right, so then the measure of angle ABC. Remember when you have 3 letters of an angle, it's the middle letter that is the angle. So A to B to C is that angle right there. And what did we say that was? 90 degrees. No math to do. That's just the theorem tells us that. And then BC, that's this distance. So I know AB is how long?
30.5.
Well, X is 30.5. So if I were to solve that, but do I have to do that? If I know that AB is congruent to AD, this side is also what? Just 48? So now I know that AB is 48, I know that AC is 52, and I know that I'm looking for BC. And what kind of triangle is this?
Right.
A right triangle, so I can use the, what theorem?
30.
The Pythagorean theorem. And so here I have a leg and a hypotenuse, and I'm trying to find the shorter leg. So am I adding or subtracting in my Pythagorean theorem?
Subtracting.
Subtracting. So 52 squared, and you always start with the larger number. The hypotenuse is the larger number. You always start with the hypotenuse minus the leg. And so 52 squared minus 48 squared, and then the square root of that is?
20.
Y'all agree? And then BC represents what part of the circle? The radius. So if you want the diameter of the circle, multiply the radius 20 times 2. And 20 times 2 is 40. All right, and then this next section, that is just a definition. When circles are inscribed in polygons, so that's an example of that there. A circle is inside a polygon. That is called circumscribed. So when you read the word circumscribed, it means that the circle is inside a polygon. And so that makes all of those sides tangents to the circle. And so we can apply the two theorems to this image. So we are given that triangle TRW is circumscribed about circle A. And if the perimeter, so we're given the perimeter of this triangle is 50, we'll hold on to that information. And then we're going to label TK3 and then WM 9.5. And now, based on our theorems, what is the measure of TL?
3.
Because that point has a tangent going to that side of that point in the circle, and that same point has a tangent line going there. That means these two sides are congruent. So that is 3. So now what else do I know?
You know you have a 9.5.
Goes where?
Right on
Use letters.
D with W.
W2
Okay.
K is also 9.5. So now I can do what with these two numbers to find this side?
Adam.
Add 9.5 plus 3 makes
12.5.
12.5. And now what's true about these two sides?
They're both 3.
Well, we don't know how much they are, but we do know that they are what? Congruent. So, to find perimeter, you add. So if I'm finding a missing piece, I'm going to do what? So let's start subtracting. I'm going to start with my perimeter of 50, and what do you think I should start subtracting?
3.
12.5.
How about 12.5 since it's the one full side? Let's start there. And so 50 minus 12.5 is
3.
37.5.
37.5? And now what do you think we should subtract?
9.5.
9.5. All right, let's do that. And we get 28. And now what do you think we should subtract? And then we get, and now that's what's left to be shared with these two sides. And we just said these two sides are congruent, so all I have to do is divide that 25 by 2. And that gives me 12.5. And so TR,
Is 12. Point.
no, sorry, that is 12.5. Just kidding. And that's 12.5. And now it asks for TR, so TR is this distance,
Yeah.
which is
15.5.
15.5. All right, so again, not new math, just some new truths that we call theorems in geometry that we are going to apply to solve problems. So here, this one's pretty straightforward. It says find the perimeter of the polygon with that circumscribes the circle. And so again, we learned that if a tangent is drawn from a point and another tangent is drawn from the same point, those two segments are congruent. So CD is
Congruent.
how many?
Right.
How much is CD?
90.
It's a side length.
Oh, 2.
It is 2. DE is 3, so EF is 3. HG is 1, so GF is,
1,
and then AH is,
3.
now all you have to do to find perimeter is
Adam.
add. I would suggest you pairing them. This is a pair, this is a pair, this is a pair, here's a pair. Then that's always how that's going to go. And so 6, 4, 6, and 2. And that is 18. All right, in example 8, we are going to use both theorems that we learned today plus things we already know to solve for each of these. So we're going to start by writing the given information. So OA is 12. O to A, that's this line here, is 12. And what did I say earlier that is true of this line? It does what to that angle? It cuts it in half evenly, right? So that's just something we need to remember. So OA is 12, OB is 6, and then B to A to C, this entire big angle A is 60 degrees. So that's my given information. And so now what is OC?
Says
Because OC is a
Radius.
radius, it is the same as OB, so it is 6. ED,
is do 12 plus 6.
E to D is the diameter, so 6 plus 6, is that what you said?
Oh, she said 12 plus 6.
So
That'd
D,
be 6 plus 6.
all right, D to E is a diameter, so it's 6 twice, so it's 12. And then A to B, now is this side of, what kind of triangle is this?
All right.
Because that is a right angle because the tangent intersects the radius. And so this right triangle has a leg of 6 and a leg of 12, so we can use the Pythagorean theorem to find AB. And so AB is a leg because it is touching the right angle, so we're going to subtract 12 squared minus 6 squared and find the square root of that for AB.
10, 4.
Let's call it, how about 4? Let's round it to 4, 10.4. Yeah, I think it's 0.39, but we'll just round it to one decimal place. So that is here. And so if AB is 10.4, what is AC?
10.4.
Because they are congruent, it is also 10.4. And now the measure of BAO, that's this part of A. Not the whole thing, but this part. So this is why it's important to remember that this line does what? It bisects that angle. So this angle is how much?
30.
Because that's half of 60. And then O to C to A.
It's also 30.
This angle right here.
Oh, 90.
That's the 90-degree angle, right? Because that's a tangent that intersects a radius. So it's perpendicular, it is 90 degrees. And then what about A to O to C?
30.
So we have this triangle A, O, C. This is how much?
30.
And then this little piece is how much?
6.
Remember, the whole thing is 60. Half of it's 30, so that leaves this one has to be
30.
90 plus 30 plus how much makes 180? 60. And we kind of should just remember that. If it's 30 and 90, the other one has to be 60, right? That's the 30, 60, 90 triangle. And then E to O to C is the same angle. AOC and EOC are both the same angle. I'm not 100% sure why. I don't know if that's a typo and they meant to ask for something else, but AOC is the same as EOC, and so it is also 60 degrees. And then the distance from E to A.
12.
O to A is 12. O to E is how much?
6.
So E to A would be 12 minus 6, which is 6. And it's a coincidence that it's half. That will not always be true, all right? That is a coincidence that it's half. Questions about any of that? So again, really no new math here. It's just a couple of new truths. Your assignment today is 20 questions. I'll get you started, and then if you need to work with someone, you can, but I think probably most of you will be okay.
Yes.
Oh, what do you do now? You gotta do this now.
All right, number 1 through 8 is just vocabulary. It does say on several of them all. So all radii. So make sure you name more than one because it does say all. So there are 3 of them, I believe. So make sure that you are answering exactly what it's asking. And then if you'll look at 9, 10, and 11, you are using Pythagorean theorem on all 3 of those. So that's going to be the first set of examples that we did. So using Pythagorean theorem. And then on the back, this is going to be using your theorems, and possibly, I think on this first one, you're trying to find the diameter, so all the way across the circle, so you do have to find, I think, AO. You have to start by finding AO using Pythagorean theorem so that you can find the diameter. And then 13 and 14, you're using what we know about the tangents being congruent. Here we're learning, again, using tangents being congruent to find x. So 14 for some reason doesn't say x equals, but you're solving for x here. And then 15, you're finding the perimeter. Everybody look at 15. You're finding the perimeter. So you're going to start, it's kind of like a puzzle. You're going to start here. What do you know about 1.8? What else is 1.8? And then perimeter is usually adding up the sides, right? So if you're undoing it, because you have to find this piece before you can find perimeter. So to find a missing piece with perimeter, instead of adding, you're going to do what? Subtract. It's a series of subtraction. All right, so make sure that you are kind of following around. Basically, you just go around this way subtracting. And then that last one, if you label these, it is okay because this label is applicable to all 5 questions. So it is okay to label this. Don't worry about having to erase things. Once you label it, it does apply to all of it, if that makes sense. All right, so make sure that you are answering those. So you have the remainder of the period. We will